Today we're going to talk about linear word problems or linear applications. So this is sort of your cheat sheet to look back and try to find keywords within a word problem and what that means in terms of the operation that you're going to use. I'm not going to read all of these, but I do want to highlight just a few important ones that you might see a lot of or ones that you might confuse. So for example, up here we've got more than. More than means addition, okay? But what happens is a lot of times people think more than is greater than, right? So we've got to be careful. It will have words like these if it's talking about greater than or less than. If you see something like you have $7 more than Susan, that would be you're adding 7 to that amount. Okay, and in the same way, less than. Less than most of the time means subtraction rather than actually the symbol less than. Okay, for multiplication, per is a big one. If I tell you something is $10 per person or $5 per ticket, then that's going to be multiplication. You also see each a lot. So if it's $5 for each person or each pen is $3, those are all going to be multiplication, okay? The other thing that I want to highlight here is maximum and minimum, because a lot of students will read maximum and they'll think, oh, greater than, because it's a high value. But if I tell you that the maximum amount that you can spend is $100, that means that you need to actually spend less than $100. And you'll have to look at the context of the problem because maximum and minimum can also go down here. If I tell you have a maximum of $100, you could spend $100, so then that would be less than or equal to. Okay, so we're going to use this context a lot within the problem and find keywords in order to set up our equations. Example 1, the North Georgia Fair costs $6 for admission plus $1.50 per ticket. So I'm already seeing some keywords in here. We've got plus, okay, which is going to mean that we're adding, and then per ticket. Okay, so when we see the word per, that means that this $1.50 is going to go with my variable per ticket. That means that's going to be $1.50x. Okay, so we can go ahead and write that down, $1.50 per ticket, because we don't know the cost of the ticket. Now you can use t instead of x, that's fine. It doesn't tell us which variable to use, so that's up to you. And then we have plus my admission cost, which the admission cost we're only paying one time. So this is going to be plus 6. Okay, now if you have $40, all right, you have $40 to spend, write and solve an equation or an inequality that represents the maximum, keyword there, number of tickets you can purchase. So a lot of people tend to just write equals 40 because I know that the amount that I can spend is 40. But if it's the maximum number that I can purchase, you might not spend all 40. So we're going to spend either less than or equal to 40. Okay, so this would be the setup for my linear inequality. So now to solve it, I just solve it like I would a regular linear inequality. So subtract 6 from both sides. 40 minus 6 is 34. And then I can divide by my $1.50. So I get x is less than or equal to 22, but then it's 0.66666, so it's 6 repeating. Well, you can't get 22.6 tickets. So this is why the word maximum was important. What's the maximum number of tickets you can get? I can't round this up to 23 because then I've spent more than my $40. So because it's maximum number, I need less than and I need to round down, which means the most that I could get would be 22 tickets. Example 2. So while at Barnes & Noble, you spent exactly $200. before tax on records and books. So if you spent exactly $200, that's not more than $200, that's not less than $200, that means you were equal to $200. Okay? Each record, each being a key word, so each record costs $20. That means that I'm going to multiply all my records by 20. Okay? So let's denote that as 20R. And each, again, another key word, book is $10. So plus $10 times each book. Okay, now I can't solve this yet because I've got two different variables. So now they give me another piece of important information. If you already bought 7 records, so that means that for R, I can substitute in 7. And now I can solve this. So 20 times 7 is 140. So that's how much I already spent on records. So I'm going to subtract that to the other side, which means that I spent 60 on books, since that's all that's left. So now I divide by 10. And I bought 6 books. Example 3, the length of a rectangle is 3 centimeters more than twice the width, and the perimeter is 48. All right, so a lot of you might have read that and already given up on the problem. So let's draw a picture of a rectangle. That might make things a little bit easier. Okay, and let's go kind of one at a time here. So the length of a rectangle is 3 more than, so again, be careful with more than, that means addition, okay? So I'm going to be adding 3 to twice the width. So how could I represent twice the width? That means times 2. So I could represent that as 2W. So let's say that this right here is the length, okay? So it's 2W. And then plus 3, because it was 3 more than twice the width. Well, if that side is 2W plus 3, then this side is also 2W plus 3. Okay, so both of those represent the length of the rectangle. So the width of the rectangle, we don't know the width of the rectangle, so we can just leave that as W and W. Right? So now I have all 4 sides of the rectangle, and it tells me that the perimeter is 48 centimeters. So I know that this is going to equal 48. So now the question is, how do I find perimeter? Remember, the formula for perimeter is 2L plus 2W. Okay, or we can just add all the sides together. So I'm going to multiply 2 times my length, which was 2W plus 3, plus 2 times my width, which was just W. All right, and now we can solve this for my width. So I can distribute. We get 4W plus 6 plus 2W equals 48. Combine like terms. So 6W plus 6 equals 48. Subtract 6. 6W equals 42. And then divide both sides by 6. So my width equals 7. And this is in centimeters, so 7 centimeters. Okay, so we're almost done, but the problem wants us to find both the length and the width. So this is my width, and I know that my length was 2W plus 3. So what I can do is I can now substitute my width back in. I know that my length is twice the width, so 2 times 7 plus 3. So the length is going to be 14 plus 3, which equals 17 centimeters. So that would be my length. Example 4, your Unit 1 assessment score was an 86 and your Unit 2 assessment score was a 79. Determine the minimum. Okay, so again, minimum doesn't mean less than. Minimum actually means I want to be greater than whatever score I want to get. So score you need to make on the Unit 3 assessment is what I need to figure out in order to have an average of 83. All right, so how do we figure out average? We're going to add all our scores together, and I don't know the Unit 3 assessment score, so I'm going to call that X. All right, so I'm going to take 86, first test, plus 79, which was my second test, plus X, and then to find the average or the mean, you would divide that by how many you took. So 1, 2, 3. And I want my test average to be an 83%. Okay, now could we get higher than an 83? Sure. Okay, do we want lower? No. So I want to be greater than or equal to 83. And now I'm going to solve this. So to get rid of the fraction, we can first multiply by 3. And that will cancel out the denominator, and then multiply the other side by 3. So I get 86 plus 79 plus X is greater than or equal to 249. And again, on this side over here, these cancel. So there's nothing to distribute to the numerator except a 1, because 3 divided by 3 is just 1, which would leave them the same. So now I can combine like terms. 86 plus 79 is 165. Plus X is greater than or equal to 249. Subtract 165 from both sides. And my grade needs to be at least greater than or equal to an 84%.